A comet passes behind the sun. On Earth, astronomers lean into their screens. Some are watching satellites. Others are watching each other. In Lexington, Massachusetts, a Harvard professor sits at his desk, writing. His name is Avi Loeb. For 4 months, he has been calling this object something most scientists refuse to say out loud. He thinks it might be alien technology. 300 miles south, in Washington, D.C., NASA headquarters maintains its position. Tom Statler, lead scientist for solar system small bodies, has said it clearly. It's a comet. The evidence is overwhelming. It behaves like a comet. Between these two positions lies one of the strangest controversies in modern astronomy, not because of what we've discovered, but because of what we're willing to consider. The object has a designation, 3I/ATLAS, the third confirmed interstellar visitor to pass through our solar system. The first was strange, the second was ordinary. This one is neither, and depending on who you ask, it's either reshaping cometary science or testing the limits of scientific imagination. The discovery, July 1st, 2025. The Asteroid Terrestrial Impact Last Alert System telescope in Chile captures something unusual, a moving object. Bright, fast, very fast. The initial calculations come back wrong. They run them again. Same result. This object is moving at 130,000 miles per hour. Its trajectory follows a hyperbolic path. It didn't orbit anything. It came from somewhere else, somewhere far away. The designation comes quickly. 3I. Interstellar Object Number 3. Within days, every major telescope on Earth pivots to look at it. Hubble James Webb, the Very Large Telescope in Chile, Gemini South, Keck 2 in Hawaii. NASA mobilizes over a dozen space-based assets. The European Space Agency does the same. This is not routine. When an interstellar object appears, the astronomical community moves with rare unity. These visitors are cosmic messengers. They carry information from other star systems, information we cannot get any other way. But this time, something is different. This time, someone with tenure at Harvard is asking questions that make other astronomers uncomfortable. The pattern of precedent. To understand the controversy, you need to understand what came before. October 19th, 2017. A telescope in Hawaii detects the first confirmed interstellar object. They name it Oumuamua. Hawaiian for scout, or messenger from afar arriving first. It's small, roughly the size of a football field, pancake-shaped, or maybe cigar-shaped. Nobody can be sure. It's tumbling end over end as it races through the solar system. Then it does something comets aren't supposed to do. It accelerates, not from gravity, from something else. It's being pushed by a force that doesn't match any known cometary process. Comets accelerate when they heat up near the sun. Ice turns to gas. The gas jets out. Newton's third law: action and reaction. The comet gets a tiny boost, but Oumuamua shows no tail, no gas plume, no visible outgassing at all. Yet it's accelerating anyway. Most astronomers settle on explanations involving hydrogen ice or outgassing too faint to detect. The data is sparse. The object is already leaving. There's not enough time to know for certain, except Avi Loeb looks at the same data and sees something different. He sees an object that's unusually shiny, tumbling in a specific way, accelerating without visible fuel, being pushed by sunlight more than it should be. He co-authors a paper. The paper suggests that if you assume solar radiation pressure is causing the acceleration, the object would need to be less than a millimeter thick, wide but thin, like a sail, like a light sail. The kind of thing that doesn't occur in nature, the kind of thing engineers design. The paper is peer-reviewed. It's published in the astrophysical journal Letters. It follows standard scientific methodology. An anomaly is observed. The standard explanation doesn't fit. An alternative is proposed. The reaction is not standard. Colleagues call it irresponsible, sensationalist, naive. Some reactions are personal, sharp, angry. The criticism goes beyond the science. It becomes about Loeb himself, his motivations, his judgment, his place in the field. Loeb publishes a book, Extraterrestrial, the First Sign of Intelligent Life Beyond Earth. In it, he compares himself to Galileo. The comparison does not help. Other scientists, including planetary astronomers Steve Desch and Sean Raymond, publish detailed rebuttals. They go through Loeb's claims point by point. They argue the evidence does support a natural comet, that Loeb has misrepresented the data. But the public is listening to Loeb, not to his critics. He's articulate, charismatic. He writes daily on Medium. He appears on podcasts, television, radio. He raises millions for the Galileo Project, an initiative to search for alien technology. By the time 2I/Borisov arrives in 2019, the damage is done. The second interstellar object is clearly a comet. Unremarkable. Ordinary. It behaves exactly as expected. Loeb says nothing about 2I/Borisov being alien. The scientific community breathes easier. Maybe the Oumuamua phase is over. Then 3I/ATLAS appears. The anomalies begin. July 2025. As observations pile up, astronomers realize this object is not like 2I/Borisov. It's massive. Diameter estimates range from 440 meters to 5.6 kilometers. Call it Manhattan-sized. 1,000,000 times more massive than Oumuamua. 1,000 times more massive than Borisov. It shouldn't be this big. Interstellar space is vast. Large objects are correspondingly rare. The probability of detecting an interstellar object this size by pure chance is extraordinarily low. By July 3rd, Loeb is already quoted in the Daily Mail. He mentions the possibility of alien technology. The quote is hedged. Careful, but it's there. Then the trajectory analysis comes back. 3I/ATLAS is moving almost exactly along the ecliptic plane. The ecliptic is the flat disk where Earth and most other planets orbit. It's where the action is in a solar system, where the planets are, where life might be. Random interstellar objects shouldn't care about the ecliptic. They come from random directions. The probability of one aligning this closely by chance is about 0.2%. Loeb seizes on this. An alien probe would aim for the ecliptic, he argues. It's the target-rich environment. The place you'd go if you wanted to observe planets. Other astronomers push back. Sample size of 1, they say. You can't calculate meaningful probabilities from a single event. And besides, we've only been looking for a few years. Selection effects could explain it. But the anomalies don't stop. The anti-tail. July 21st, 2025. Hubble Space Telescope captures high-resolution images of 3I/ATLAS. The images show a coma, a glowing envelope of gas and dust, normal for a comet. They also show something else. A narrow jet, pointing toward the sun. Comets have tails. Everyone knows this. The tails always point away from the sun. Solar radiation pushes gas and dust outward. The tail streams behind the comet like a pennant in the wind. But 3I/ATLAS has a jet pointing the wrong way. An anti-tail. Astronomers have seen anti-tails before. Usually they're optical illusions, a trick of perspective. You're looking at the tail edge on, and it appears to point sunward even though it doesn't. But this one is real. Hubble sees it. Multiple telescopes confirm it. It's an actual jet of material moving toward the sun. This violates basic physics. Solar radiation should push everything away, not toward. Unless something else is causing the jet. Loeb points out that such a jet could be evidence of maneuvering, a thruster, a controlled burn. The kind of thing a spacecraft might do. Cometary scientists point out that anisotropic outgassing can cause jets in unusual directions. Volatile ices on one side of the nucleus heat up and vent asymmetrically. The nucleus rotates. The geometry gets complicated. Anti-sunward jets are possible under specific conditions. Both explanations are plausible. Neither is proven. The controversy deepens. The nickel problem. August 2025. Spectroscopic observations from the Very Large Telescope in Chile detect something unprecedented. Nickel vapor. Lots of it. At first, this doesn't seem anomalous. Comets occasionally show metal emissions. Nickel and iron appear together. They're forged together in supernovae. They travel together through space. Where you find one, you find the other. Except 3. I/ATLAS is emitting nickel without iron. This has never been observed in any comet. Ever. The production rate of nickel increases dramatically as the object approaches the sun. But iron remains absent. Undetectable. Nickel and iron are cosmic twins. They shouldn't separate. Their chemistry is linked. Their abundances are tied. Their behavior is coupled. Yet here is nickel vapor with no iron counterpart. Planetary scientists propose an explanation. Nickel tetracarbonyl. A volatile organometallic compound, NiCO4. It can form in cold, carbon-rich environments. It sublimates at low temperatures, much lower than the temperatures needed to vaporize pure nickel metal. If 3I/ATLAS formed in a protoplanetary disk with abundant carbon monoxide, nickel tetracarbonyl could have been trapped in the ice. As the comet warms, the compound breaks down. It releases nickel atoms. But iron compounds are more stable. They remain locked in the nucleus. This would be a new class of comet. Exotic chemistry. Never seen before, but natural. The explanation is published. It's peer-reviewed. It fits the data. But there's a problem. Nickel tetracarbonyl is not found in nature on Earth. It exists in one place. Industrial refineries. The Mond process. A metallurgical technique invented in 1890 to purify nickel. You heat nickel in the presence of carbon monoxide. Nickel tetracarbonyl forms. It's a gas. You collect it. Heat it again. Pure nickel plates out. The process is used in factories, not in comets. Avi Loeb does not let this go. This was a process that we can imagine only because it was used in industry, he writes. Never seen in comets before. He's not saying it's impossible for nature to produce nickel tetracarbonyl. He's saying the signature is suspiciously similar to human industrial processes. And if humans figured out how to use this chemistry for metallurgy, maybe another civilization did too. For a different purpose. The Loeb scale. By October 2025, Loeb has formalized his thinking. He co-authors a paper introducing the Loeb scale, a ranking system for interstellar objects. 0 means definitely natural. 10 means definitely technological. He assigns 3I/ATLAS a rank of 4 out of 10. The ranking is based on 8 anomalies. Ecliptic alignment, 0.2% probability. Anti-sunward jet. Large size. Million times more massive than Oumuamua. Close approach to Venus. November 3rd, 2025. Close approach to Earth. December 19th, 2025. Close approach to Jupiter. March 16th, 2026. Nickel emission without iron. Extreme nickel production rates. Each anomaly, taken alone, might have a natural explanation. But together, they paint a picture that bothers Loeb. A large object, moving along the ecliptic, passing near multiple planets, exhibiting chemical signatures associated with industrial metallurgy. He doesn't claim it's alien. He says there's a 40% chance. The number is specific, deliberate. It's meant to be taken seriously. Most astronomers don't take it seriously. Jason Wright, an astrophysicist at Penn State who actually searches for technosignatures, writes a detailed blog post. He calls Loeb's analysis very, very bad science. Wright points out basic observational errors. Loeb dismisses the extended coma around 3I/ATLAS, claiming it's just image smearing from improper tracking. But any undergraduate astronomer knows how to track moving objects. Telescopes have been doing it for over a century. The extended coma is real. It's evidence of cometary activity. Gas and dust streaming off the nucleus. The hallmark of a comet. Wright's frustration is palpable. Loeb is making claims outside his area of expertise. He has no formal training in planetary science. His specialty is plasma physics and cosmology. Yet he's contradicting career-long comet experts. And the media is amplifying his voice while ignoring theirs. Most planetary scientists rightly do their best to ignore him, Wright writes. But it's important that someone engage his claims seriously and explain to the public what is right and wrong about them. The problem is that Loeb is not wrong about everything. Some of his observations are correct. The anomalies are real. The nickel signature is unprecedented. The trajectory is unusual. What's debatable is the interpretation. The acid test. October 29th, 2025. 3I/ATLAS reaches perihelion, its closest approach to the Sun. Loeb calls this the acid test. If 3I/ATLAS is a natural comet held together by weak ice, the intense solar heating should break it apart. Fragments would evaporate rapidly. The brightness would surge. A spectacular fireworks display. If it's a technological artifact, built from stronger materials, it should survive intact. It might even maneuver. Change velocity. Release smaller probes. The object passes behind the Sun, from Earth's perspective. Ground-based telescopes lose sight of it. But spacecraft still see it. Goes 19 weather satellite. SOHO Solar Observatory. Stereo A. The Punch mission. All maintain visual contact. NASA has mobilized an unprecedented array of assets. Mars Reconnaissance Orbiter, Perseverance Rover, Curiosity Rover, Europa Clipper, Lucy, Psyche, Parker Solar Probe, Punch, Hubble, Webb Sphere X, TESS, Swift. The European Space Agency deploys Mars Express and ExoMars Trace Gas Orbiter. Both attempt to image 3I/ATLAS as it passes near Mars on October 3rd. The cameras are designed for Mars, not for faint comets. But ExoMars succeeds in capturing a fuzzy white dot. The comet is 10,000 to 100,000 times fainter than the orbiter's usual target. It's still there, still intact. The high-rise camera on Mars Reconnaissance Orbiter takes the highest resolution images yet. At a distance of 30 million kilometers, it achieves a resolution of 30 kilometers per pixel, 3 times sharper than Hubble's earlier images. NASA promises to release the data. Then the U.S. government shuts down on October 1st. Data sharing from NASA missions stops. The high-rise images remain unpublished. As of October 31st, they still haven't been released. Loeb writes about this on his Medium blog. Daily posts. He notes the timing, the perihelion passage, the solar occultation, the opportunity for a clandestine maneuver. He's not claiming NASA is hiding anything, but he's asking why the most critical images haven't been shared. NASA's Tom Statler, when asked about the delays, says the evidence overwhelmingly points to a natural comet. It has some interesting properties that are a little bit different from our solar system comets, but it behaves like a comet. The statement is careful, measured. It acknowledges the unusual properties, but it maintains the natural explanation. Most scientists agree with Statler, but they also acknowledge the tension. The data is unusual enough that it deserves careful study. Dismissing it as just a comet misses the scientific value. Even comets can surprise us. The Dark Forest. Loeb and his co-authors published a paper in October exploring a darker possibility. Is the interstellar object 3I/ATLAS alien technology? The paper is framed as a pedagogical exercise, a thought experiment. What if it is alien? What would that mean? They invoke the dark forest hypothesis, a proposed solution to the Fermi paradox. If the galaxy is full of civilizations, why haven't we heard from them? Perhaps because they're hiding, staying silent. Broadcasting your presence might attract attention from hostile civilizations. Better to stay dark. Stay quiet. Watch from the shadows. If 3I/ATLAS is a probe from such a civilization, its trajectory makes sense. Approach along the ecliptic, maximum coverage of planets, pass behind the sun at perihelion. Perfect opportunity for a maneuver. Hidden from Earth's view. The paper calculates the probability of 3I/ATLAS's close approaches to Venus, Mars, and Jupiter. If it arrived at a random time, the chance of passing this close to all 3 planets is about 0.005%. 0.005%. The authors note that 3I/ATLAS's approach from the direction of the galactic center made it difficult to detect early. It came from a bright region of sky. Background light swamped the signal. By the time it was discovered, any chance of an intercept mission was gone. An optimal trajectory would have required launching in July 2024, a full year before detection. The paper includes diagrams, trajectory plots, statistical calculations. It's rigorous, peer-reviewed, published on ARXIV. It's also deeply uncomfortable. The authors are not claiming 3I/ATLAS is hostile, but they're not ruling it out. They're applying Pascal's wager to astrobiology. The potential benefits of taking the possibility seriously far outweigh the costs of being wrong. If it's alien and benign, we should be prepared to communicate. If it's alien and malign, we should be prepared to defend. If it's natural, we've still advanced our understanding of interstellar objects. Most scientists find this reasoning unpersuasive. The prior probability of alien technology is so low that even significant anomalies don't shift the balance. Extraordinary claims require extraordinary evidence, and the evidence for 3I/A TLAS being a comet, while imperfect, is still far stronger than the evidence for it being a probe. The scientific method under stress. The controversy over 3I/ATLAS exposes something deeper than a disagreement about one object. It exposes a tension in how science handles radical uncertainty. Avi Loeb argues that science should be open to all possibilities, that ruling out alien technology without investigation is a form of prejudice, that the search for extraterrestrial intelligence deserves the same respect as any other field. His critics argue that science requires discipline, that not all hypotheses deserve equal consideration, that the burden of proof lies with extraordinary claims, that promoting untested ideas to the public damages scientific credibility. Both positions have merit. Both have risks. Loeb's approach risks sensationalism. It invites media hype. It can make real scientists look like fringe theorists. It can undermine public trust in expert consensus. But the traditional approach has risks too. It can ossify into dogma. It can punish original thinking. It can create taboo topics where legitimate questions aren't asked, because asking them damages careers. The study of extraterrestrial intelligence has historically been stigmatized. Scientists who pursue it face skepticism from peers, difficulty getting funding, reduced job prospects. Loeb, with tenure at Harvard, doesn't face those pressures. He can ask questions others can't. He can take risks. He can be wrong publicly and survive. This is what tenure is for, he argues, to protect intellectual freedom. His critics counter that with freedom comes responsibility, that using tenure to promote poorly supported ideas is an abuse of privilege. The debate is not just about 3I/ATLAS, it's about the boundaries of acceptable speculation, about who gets to set those boundaries, about how science balances openness with rigor. The chemistry deepens. As October turns to November, new data continues to arrive. The Very Large Telescope in Chile publishes additional spectroscopic analyses. The nickel emission is even more dramatic than initially reported. Production rates increased by orders of magnitude as 3I/ATLAS approached the Sun. At 3.9 astronomical units, the emission rate was barely detectable. By 2.85 AU, it had exploded. Iron remained absent throughout. The paper's authors confirm the presence of cyanide alongside nickel. Both show asymmetric emission patterns. Both extend hundreds of kilometers from the nucleus. Both point partially toward the Sun. The chemical fingerprint is unique. Unlike any comet in our solar system. Unlike 2I/Borisov. The James Webb Space Telescope adds more detail. The coma is 95% carbon dioxide by mass, only 4% water. This is the reverse of typical comets, which are mostly water ice. The CO2 to H2O ratio is 6 standard deviations away from the solar system comet average. 6 sigma. In particle physics, that's the threshold for claiming a discovery. It means the probability of this being a statistical fluke is about 1 in a billion. 3I/ATLAS is not like solar system comets. That much is certain. The question is why? Natural exotic versus artificial simple. By early November, 2 narratives have crystallized. Narrative 1. 3I/ATLAS represents a new class of interstellar comet. Its chemistry reflects the environment where it formed. Billions of years ago, in a protoplanetary disk around a different star. Perhaps an older star. Perhaps a star with a different metallicity. Perhaps a disk with unusual abundances of carbon monoxide. The nickel tetracarbonyl formed naturally, trapped in ice for eons, now releasing as the comet warms. The size is unusual, but not impossible. Large interstellar objects are rare, but the universe is vast. We've only been looking for a few years. Selection effects favor detecting large, bright objects. Smaller ones pass unnoticed. The ecliptic alignment is coincidence, or selection bias, or both. The anti-tail is real, but natural. Complex rotation. Asymmetric outgassing. Unusual, but not unprecedented. Under this narrative, 3I/ATLAS is a scientific goldmine. It's teaching us that cometary chemistry is more diverse than we thought, that different star systems produce different kinds of icy bodies, that interstellar space is stranger than we imagined. But it's still nature, still physics and chemistry, following natural law. Narrative 2. 3I/ATLAS is simple if you accept one unusual premise. It's artificial. A probe, built by a civilization with advanced metallurgy, coated with materials that sublimate in specific ways, designed to maneuver using solar heating, aimed at the ecliptic to maximize planetary encounters. The nickel signature isn't strange chemistry. It's industrial material outgassing under thermal stress. The size makes sense. A mothership. Large enough to carry instruments. Possibly autonomous probes. The trajectory isn't coincidence. It's planning. Under this narrative, 3I/ATLAS represents first contact. Not with living beings, but with their technology. A message from another civilization. Whether that message is friendly or hostile remains unknown. Both narratives fit the data. Neither is proven. Neither is disproven. This is the problem. The waiting game. November 2025. 3I/ATLAS emerges from behind the sun. Ground-based telescopes regain visibility. According to NASA's predictions, the comet should be observable again by early December. Stargazers with telescopes may see it in the pre-dawn sky starting November 11th. The European Space Agency's JUICE spacecraft will attempt observations in mid-November. Despite being farther from the comet than the Mars orbiters were, JUICE will deploy multiple instruments. JWST is scheduled for additional observations in December, after perihelion. Hubble will perform ultraviolet spectroscopy in November to measure sulfur to oxygen ratios and determine gas composition more precisely. The high-rise data from Mars Reconnaissance Orbiter still hasn't been publicly released. The government shutdown is over, but NASA moves slowly. Scientific review takes time. Loeb writes daily updates on his Medium blog. He catalogs anomalies. He responds to critics. He maintains that the technological hypothesis deserves consideration. Most astronomers continue working quietly, publishing papers, analyzing spectra, building models. They're excited about 3I/ATLAS, but not because they think it's alien. They're excited because it's scientifically valuable, a genuine interstellar comet, a sample from another star system, a window into planetary formation processes we can't observe directly. The media attention is distracting, but the science continues. The precedent of Oumuamua. The story of 3I/ATLAS cannot be separated from the legacy of Oumuamua. Oumuamua split the astronomical community, not about what it was, but about how to talk about what it might be. Most scientists concluded it was a comet or asteroid. Unusual, yes, but natural. Loeb argued it might be artificial. He published papers, wrote a book, founded the Galileo Project, raised millions in funding. His critics argued he misrepresented the data, that his claims were overblown, that he was damaging the credibility of legitimate SETI research. The controversy became personal, bitter, unproductive. Now with 3I/ATLAS, the pattern is repeating. The same arguments, the same accusations, the same frustrations, but this time, the data is richer. The observations more detailed, the anomalies more numerous. And this time, more scientists are uncomfortable dismissing the unusual properties. Not because they think it's alien, but because they're recognizing that it's just a weird comet is becoming a less satisfying answer. If 3I/ATLAS is natural, it's forcing us to expand our understanding of cometary chemistry, to accept that interstellar comets can have wildly different compositions than solar system comets, that our sample size is too small to know what's typical. If it's artificial, we face implications beyond astronomy, beyond science. Implications for humanity's place in the cosmos. Neither outcome is simple. The data everyone wants. As of October 31st, 2025, the scientific community is waiting for 3 critical pieces of data. First, the high-rise images from Mars Reconnaissance Orbiter. These are the highest resolution images available. They should show whether 3I/ATLAS has a large nucleus or a dense coma, whether the brightness comes from solid material or from gas and dust. If the brightness is concentrated in a compact nucleus, it suggests solid structure, possibly artificial. If it's diffuse, spread across a wide coma, it confirms cometary behavior. The data exists. It was captured on October 2nd. It remains unpublished. Second, the post-perihelion observations from JWST. Scheduled for December, these will show how 3I/ATLAS behaves after its closest solar approach. Did it fragment? Did it brighten dramatically? Did its chemistry change? Or did it pass through perihelion intact and unchanged? Natural comets often fragment or outburst at perihelion. The thermal stress is enormous. Weakly bound material breaks apart. Artificial structures, built from engineered materials, would survive better. Third, the trajectory update. After perihelion, has 3I/ATLAS's velocity or direction changed? Even a tiny maneuver would be detectable, a thrust of a few meters per second, a course correction of a fraction of a degree. If the trajectory has changed in any way, not explained by gravitational forces, it's a game changer. If it continues on a purely ballistic path, it supports the natural hypothesis. These 3 data sets will not end the controversy, but they will constrain it. The personal story. Behind the technical debate is a human story. Avi Loeb is 63 years old, born on a farm in Israel, raised surrounded by chickens. His father taught him about philosophy. His mother taught him about hard work. He excelled in physics, earned his PhD at 24, became a professor at Harvard at 33, chair of the astronomy department at 39. He's published over 1,000 papers, trained dozens of graduate students, served on presidential advisory councils. He's been extraordinarily successful by any conventional measure. But his daughter, Lodem, says the backlash has been hard on him. He's received a lot of backlash recently, she told Cambridge Day. But at his core, he's just trying to be the scientist and curious person that he feels society needs him to be. Loeb describes walks with his daughter where he would point out plants and talk about their properties. His love of nature. His curiosity about the world. This is not a man seeking publicity for its own sake. This is someone who genuinely believes the questions he's asking are important. His critics see it differently. They see someone who has strayed from his area of expertise, who makes headlines by contradicting experts, who uses his prestigious position to promote ideas most specialists find unconvincing. Jason Wright, who criticizes Loeb's 3I/ATLAS analysis, is careful to note that Loeb has done important work in other areas, that he's a legitimate scientist, that the criticism is about this specific claim, not about his entire career. But the personal attacks have been harsh. Social media mocks him. Colleagues dismiss him. News articles question his motives. Tony Pan, a former graduate student, says meeting Loeb changed his view of academia, that Loeb encouraged curiosity and independent thinking, that he made science feel welcoming. Other students have had different experiences. Some of Loeb's recent work has been criticized by his own collaborators. Disagreements about how to present findings, about how much to speculate. The man at the center of this controversy is complex, brilliant, but stubborn, visionary, but sometimes careless, brave, but sometimes reckless. He believes tenure exists to protect unpopular ideas. His critics believe it comes with responsibility not to misuse that protection. Both might be right. The NASA position. NASA's official position on 3I/ATLAS is clear and consistent. It's a comet from another star system, scientifically valuable, not a threat to Earth. Tom Statler, speaking for NASA, has been measured and professional. He acknowledges the unusual properties. He emphasizes the cometary behavior. He affirms that the evidence points to a natural origin. NASA's response has been to mobilize unprecedented observational resources, over a dozen space-based assets, coordination with international partners, data sharing with the global astronomical community. This is not the behavior of an agency hiding anything. This is the behavior of an agency taking the object seriously as a scientific opportunity. But NASA is also cautious. The agency operates in a political environment, congressional oversight, public scrutiny, media amplification of any controversy. NASA cannot afford to speculate about alien technology without extraordinary evidence. The reputational risk is too high. The potential for misunderstanding, too great. So NASA sticks to what it can prove. It's a comet. It shows cometary activity. It has a coma and tail. It's outgassing. The unusual chemistry? Interesting. Worth studying. But not proof of anything extraordinary. This position is scientifically sound. It's also frustrating to people who want answers about the anomalies. The European perspective. The European Space Agency has been less vocal, but equally engaged. Mars Express and ExoMars, Trace Gas Orbiter, both attempted observations. ESA's JUICE mission will continue monitoring as the comet moves outward. European ground-based telescopes, including the Very Large Telescope, have provided some of the most detailed spectroscopic data. ESA's public statements mirror NASA's. This is a scientifically valuable interstellar comet. Its unusual properties make it interesting, not alarming. There's no transatlantic disagreement about 3I/A, TLAS. The scientific consensus spans continents. It's a comet. But European scientists have been slightly more willing to acknowledge the genuine strangeness. The nickel emission is unprecedented. The chemical composition is anomalous. These are facts worth emphasizing, not downplaying. The difference is subtle, but it's there. A slightly greater willingness to say, we don't fully understand this, rather than, it's just a weird comet. The Internet's verdict. Online, 3I/ATLAS has become something else entirely. Clickbait headlines, conspiracy theories, AI-generated images, claims of defense protocols, Fibonacci signals, hidden messages. Some social media posts claim 3I/A, TLAS, is targeting Earth, that it will impact in December, that governments are covering up the threat. None of this is true. 3I/ATLAS's trajectory is well determined. It comes no closer than 1.8 astronomical units, about 170 million miles. Farther than the Sun. Other posts claim NASA is concealing evidence of alien activity, that the high-rise images show a spacecraft, that the government shutdown was deliberate to suppress information. Again, none of this has evidence. The high-rise data delay is bureaucratic, not conspiratorial. But the speculation spreads. It mutates. It detaches from reality. Avi Loeb's 40% probability estimate becomes, Harvard scientist says it's definitely aliens. His careful hedging is lost, qualifications ignored. NASA's scientific caution becomes, NASA denies obvious evidence. Their measured statements are reinterpreted as cover-ups. This is the modern challenge of science communication. Truth gets compressed. Nuance gets lost. Uncertainty becomes certainty. Questions become claims. Both Loeb and NASA are fighting this distortion, but with limited success. The Internet has its own momentum. Let's be precise about what we actually know. 3I/ATLAS has a hyperbolic trajectory with an eccentricity greater than 1. This proves it's interstellar, not bound to the Sun, not from our solar system. Its incoming velocity relative to the local standard of rest suggests it's been traveling for millions, maybe billions of years. Its origin point lies somewhere near the constellation Lyra, though uncertainties make that more poetry than map. Its brightness curve doesn't fit known models. It rose faster than expected, plateaued, and then brightened again near perihelion. Not the smooth increase seen in typical comets. Not the predictable reflection curve of a solid body. Something else. Its rotational period is unclear. Light curve data suggests precession, a complex, possibly tumbling motion. That could be natural. It could also be controlled. And yet, there are no radio emissions, no narrowband signals, no detectable communications. The Allen telescope array scanned for weeks. Silence. Either it's not transmitting, or it's transmitting in a way we can't hear. This silence cuts both ways. For skeptics, it reinforces the natural explanation. For believers, it invites imagination. Maybe it communicates through lasers, neutrinos, or quantum entanglement. Maybe it doesn't communicate at all. Maybe it simply observes. For now, it remains a riddle made of nickel, carbon dioxide, and light. The nature of evidence. In science, data rarely speaks alone. It's interpreted through frameworks, through what philosophers call priors. And in this case, the priors are heavy. We have no confirmed evidence of extraterrestrial technology. None. So the prior probability that any given anomaly is artificial is extraordinarily small. That's why most scientists demand overwhelming evidence before even entertaining the idea. But as Loeb points out, this logic can become circular. If we never allow for the possibility of artificiality, then no evidence will ever be enough. The prior becomes a shield, not of reason, but of habit. Jason Wright, one of Loeb's most articulate critics, agrees in part. He argues that the search for technosignatures should be systematic, not anecdotal. That we need protocols, ways to test the artificial hypothesis without defaulting to ridicule or sensationalism. SETI, he says, should not be religion or rebellion. It should be methodology. Yet 3I/ATLAS exposes how fragile that boundary is. Each new data point reopens the question. Each unexplained anomaly invites both wonder and suspicion. Science at its best is designed for this tension. It thrives on doubt. But modern science also operates under social pressure, funding cycles, institutional inertia, media narratives. The cost of being wrong publicly can outweigh the reward of being right privately. That's the paradox at the heart of 3I/ATLAS. The more extraordinary the claim, the less room there is to explore it. A mirror for civilization. In a strange way, 3I/ATLAS has become less about itself and more about us. It's a mirror reflecting our anxieties about truth, authority, and the limits of knowledge, about who gets to speak and who gets silenced, about how much uncertainty we can tolerate in an age that demands constant certainty. It's also a mirror for our collective imagination. The idea of alien technology evokes deep archetypes. Prometheus, Babel, the monolith in 2001. The notion that something not of us might look back is both terrifying and intoxicating. Psychologists call this the contact paradox, the tension between our desire for discovery and our fear of what that discovery might mean. If 3I/ATLAS were confirmed artificial tomorrow, it wouldn't just rewrite astrophysics. It would rewrite history, religion, politics, even art. Every story about who we are would need revision. And yet the most likely outcome is more mundane. That it's natural. Exotic, yes, but not miraculous. A chunk of chemistry that challenges our models but not our worldview. Maybe that's why the debate feels so charged, because beneath the data is the hunger for something larger, a longing for meaning disguised as scientific curiosity, the silence between stars. By January 2026, 3I/ATLAS begins to fade from view. The data sets are archived, papers are written, conferences scheduled, no smoking gun, no signal, no definitive answer. For some, it's a relief, another mystery folded back into the vastness of natural law. For others, it's a disappointment, a missed opportunity for revelation. But the legacy lingers. Funding for interstellar object studies increases. A new mission proposal, Vanguard, aims to intercept the next incoming interstellar body within days of detection. It's modeled after the interstellar probe concept, but scaled for rapid response. Loeb's Galileo project is listed as a collaborating partner, alongside NASA and ESA. For the first time, the artificial hypothesis has institutional legitimacy, not because it was proven, but because it refused to go away. 3I/ATLAS becomes a case study in scientific ambiguity. In textbooks, it's cited alongside Oumuamua as a turning point, the moment when humanity realized that the line between the natural and the artificial, at cosmic scales, may be thinner than we imagined. The human question. At a symposium in Boston, Avi Loeb gives what he calls the humility lecture. He stands before an audience of students and peers, slides flickering behind him. Comets, spectra, equations. Then he pauses. What if, he says, the most important thing about 3I/ATLAS isn't what it was, but what it showed us about ourselves, about how we respond to mystery, about how fragile our confidence in knowledge really is? Silence. Cameras click. The room is still. He continues. We may never know whether 3I/ATLAS was natural or artificial, but we do know that it forced us to confront our assumptions. That science is not a fortress, but a conversation. That we must be brave enough to ask questions others fear to ask, and disciplined enough to accept when the answer is silence. Later critics will call it self-indulgent. Admirers will call it profound. But everyone will agree it marks the end of an era, the point where curiosity reclaimed its place from certainty. Epilogue. The sky remembers. Months later, as the comet recedes into interstellar darkness, its trail still glows faintly in archived data. A few amateurs continue tracking it, mapping its faint tail across the outer solar system. In one frame from a remote observatory in Chile, a faint flash appears, a brief non-recurring spike of reflected light. Not bright enough to be an event, not long enough to be an error, just a blink. It could be a cosmic ray. It could be noise, or it could be something else. No one claims it's alien. No one can prove it's not. And so, 3I/ATLAS passes into legend, not as proof of life, but as proof of wonder. A reminder that the sky is still vast, that the frontier between knowledge and imagination is not a wall, but a horizon, and that somewhere, beyond that horizon, perhaps something is watching, just as we are. The Archive of Anomalies. By mid-2026, 3I/ATLAS has faded beyond the reach of even the most powerful telescopes. Its final measurements have been cataloged, cross-checked, and buried in databases. Lines of numbers. Quiet and inert. But in the background, something has shifted. Institutions once cautious about techno-signature research begin to create new funding lines. NASA's astrobiology program quietly adds a new division. Exotic naturalism, dedicated to studying phenomena that challenge existing models but resist extraordinary claims. It's a bureaucratic compromise, the middle ground between Loeb's boldness and Statler's restraint. At the University of Cambridge, a graduate student named Mina Okafor starts a project called the Atlas Ledger, an open database collecting all known anomalies in cometary behavior, past and present. Her idea is simple. Maybe patterns exist that we've ignored. Within months, the ledger grows. Dozens of small, strange cases appear. Nickel emissions, asymmetrical tails, unexplained rotational shifts. None are as dramatic as 3I/ATLAS, but together, they whisper a pattern. It's like the universe has been trying to tell us something, she says in an interview. We just haven't been listening closely enough. Her statement is quoted endlessly, stripped of nuance, turned into a slogan. The universe is trying to tell us something. Loeb smiles when he reads it. His critics groan. But the phrase sticks. The reformation of SETI. The search for extraterrestrial intelligence had been stagnating for decades, until 3I/ATLAS. Now suddenly, it's fashionable again. New telescopes are proposed, not to listen for radio signals, but to look for physical artifacts. Techno-signatures in motion. The Galileo project expands its charter. It partners with private observatories and AI-driven sky surveys. The goal? Identify transient anomalies in real time. Loeb calls it archaeology of the future. Jason Wright, once one of his sharpest critics, joins a new consortium called the Interstellar Initiative. He still disagrees with Loeb's methods, but he recognizes the value of the conversation. If nothing else, he says, 3I/ATLAS forced us to build better tools for doubt. A quiet detente forms between the two camps. Skeptics and dreamers. Rigor and imagination. Each realizing they need the other to move forward. At the SETI Institute, Jill Tarter, retired but still sharp, publishes an op-ed. 3I/ATLAS didn't prove aliens exist. It proved that alien hypotheses can no longer be dismissed out of hand. Science is not the act of saying no. It's the discipline of asking what if responsibly. For the first time in years, donations pour in. The cultural echo. Outside the labs, 3I/ATLAS becomes myth. Documentaries, novels, podcasts with ominous titles like The Visitor and The Comet That Spoke. Artists reinterpret its shape as sculpture, glasswork, drone ballet. A pop musician releases an album called Nickel Sky. Its cover a shimmering blur modeled on the VLT images. Conspiracy forums, of course, persist, but mainstream culture adopts a gentler fascination. Where earlier generations had UFOs, this one has interstellar objects. Clean, data-driven, respectable. Even theology adapts. A Jesuit astronomer at the Vatican Observatory gives a sermon comparing 3I/ATLAS to the Star of Bethlehem, a light that calls us not to worship, but to wonder. In classrooms, science teachers find that students who once tuned out physics now ask about trajectories, eccentricities, outgassing dynamics. They want to understand how we know what we know, and how we decide what counts as proof. The comet becomes a teaching tool, a parable of uncertainty, the scientific reckoning. In 2027, a comprehensive synthesis paper appears in Nature Astronomy. 3I/ATLAS, a multidisciplinary analysis of an interstellar comet. It spans 90 authors, 23 institutions, 1,400 references. Its conclusion: all current data are consistent with a natural origin, though certain parameters remain unexplained under existing models. The phrase "remain unexplained" becomes infamous. For Loeb's supporters, it's validation. For skeptics, it's precision. For journalists, it's a headline. But buried deep in the appendix is a peculiar graph, an outgassing model that fails catastrophically when nickel and cyanide emissions are cross-correlated. The model assumes a homogeneous nucleus. It fails because the emission sources appear discrete, not random. Localized, structured. Could be coincidence, says one reviewer. Or could mean something we don't yet understand. The authors leave it there. A footnote at the edge of knowledge. The fourth object. In August 2028, the Vera Rubin Observatory in Chile detects something faint but fast, another hyperbolic intruder. The third was 3I/ATLAS. This one becomes 4I/ZEPHYR. It's smaller, dimmer, and behaves differently. No nickel, no cyanide, no mystery. A normal comet from an alien star. Proof that interstellar debris is common. And yet, its very ordinariness sharpens the contrast. If Zephyr is typical, then 3I/ATLAS truly was strange. A paper in the astrophysical journal Letters states it bluntly. If 4I/Zephyr represents the median case, then 3I/ATLAS represents the 0.1% tail of the distribution. An outlier by every measurable criterion. Some suggest that makes it scientifically unique. Others whisper the word designed. The machine hypothesis. By 2029, a fringe but increasingly sophisticated idea gains traction that interstellar probes could masquerade as natural bodies, using sublimation, tumbling, and outgassing as camouflage. The math, disturbingly, works. No one claims it's proof. But suddenly, the idea that intelligence could be indistinguishable from nature becomes a legitimate research topic. Loeb's final thesis. In 2030, Avi Loeb publishes his final book, Silence is Data. It's part memoir, part scientific manifesto. He opens with a line that echoes through the decade, "If we wait for the universe to speak in our language, we may never hear it." On a cold night in January 2040, an amateur astronomer in Finland aims a new deep sky camera toward the coordinates of 3I/ATLAS's outbound path. He expects nothing. He just wants to practice his tracking algorithms. Hours later, reviewing the stacked frames, he notices a faint dot where no cataloged object should be. It's not moving fast enough to be a meteor, not bright enough to be a star. He marks it, compares it to the old trajectory. It aligns almost perfectly with where 3I/ATLAS should be, extrapolated 15 years later. He posts the image online with a note, "I think I found the visitor again." No one believes him at first, but then others check. And slowly, the confirmation rolls in. The object still shines, faint but steady. No tail, no coma, no outgassing. Just a point of light, cold and clean, coasting through the dark. The media barely notices. There's no controversy this time, no debate. Just a few astronomers trading quiet messages across time zones, acknowledging a familiar friend. Loeb, now retired, receives an email from a former student. It's still there. He replies hours later. So are we. The final reflection. In the end, the story of 3I/ATLAS isn't about aliens or comets or even science. It's about how humanity learns to live with the unknown. Every generation meets its mystery. For the 17th century, it was motion. For the 20th, it was quantum. For the 21st, it may be contact. Not the cinematic kind, not lights in the sky or ships in orbit, but a subtler, quieter kind of contact between our curiosity and the universe's indifference. We stare at the sky, and the sky stares back. Somewhere in that mutual silence, meaning flickers. Not proof, not certainty, just the possibility that we are part of something vast, patient, and aware. Children trace its path on planetarium domes, their eyes wide, their questions endless. Old scientists, half retired, still mention it in lectures. The one that changed how we think about evidence. It becomes a parable, whispered in observatories. The universe rewards patience, not certainty. Somewhere, in the deep interstellar dark, the object keeps moving. No engines. No tail. Just momentum and mystery. Maybe it's nothing more than stone and ice. Maybe it's something we were meant to notice and then let go. Either way, the message remains, written not in code, but in reflection. That wonder is not a conclusion. It's a direction. The sky is quiet again, but now we listen.